China is building the future, from impossible mega bridges to the world's largest structures and ultra-fast maglev trains. This will change everything.
What if I told you that somewhere on Earth, entire cities are rising from empty land in just a few decades? Bridges stretch so far they vanish into the horizon, and machines are powerful enough to reshape rivers, mountains, and even the future itself. This is not science fiction. This is not a simulation. This is happening right now in China, a nation where engineering has gone beyond imagination, a place where the future is no longer a promise. It is a reality being built in real time. In China, mega projects are not rare. They are everywhere. Massive structures emerge where nothing existed before. Entire districts are built from scratch. Transportation systems move at speeds once thought impossible. Architecture defies gravity, and technology evolves at a pace the rest of the world struggles to follow. This is a country transforming not just its own landscape, but the future of humanity itself. Welcome to a world of impossible bridges, futuristic megacities, record-breaking skyscrapers, and engineering miracles that seem decades ahead of their time. This is China. In Shanghai, the future doesn't wait. It already exists. The city skyline rises like a monument to ambition. Steel, glass, and light stretch endlessly toward the sky, creating one of the most breathtaking urban landscapes on Earth. But Shanghai isn't just about building higher. It is about building smarter. One of the most extraordinary examples is 1,000 Trees, a revolutionary architectural complex designed by Thomas Heatherwick. At first glance, it looks unreal, as if a forest has grown vertically out of concrete. Each level is covered with real trees and green platforms, transforming the structure into a living ecosystem. These trees help reduce urban heat, improve air quality, and bring nature back into one of the world's busiest megacities. And perhaps the most surprising part? It's not a park. It's a fully functional commercial, cultural, and social complex. People shop here, work here, walk here, relax here, surrounded by greenery in the middle of a massive city. This is what makes China fascinating. Innovation here is not only measured by size or speed, but by how radically life itself can be redesigned. But if Shanghai represents the future of urban living, then the Three Gorges Dam represents the raw power of human engineering. Three Gorges Dam, located near Yichang, this colossal structure is the largest hydroelectric power station on Earth. Its generating capacity reaches an astonishing 22.5 gigawatts, enough electricity to power millions of homes for an entire year. To understand that scale, imagine supplying energy to a city the size of Los Angeles, continuously, using the force of water alone. The dam transforms the immense power of the Yangtze River into clean energy, reducing dependence on fossil fuels while helping power one of the largest economies on Earth. But the most shocking fact is not its power. It is its size. The reservoir behind the dam is so massive that scientists, including researchers from NASA, noted that the redistribution of water mass slightly affects Earth's rotation. The effect is tiny, almost imperceptible, but real. A human-made structure so enormous it can influence the planet itself. And yet with all that power comes responsibility. The dam also protects more than 400 million people downstream from catastrophic flooding. But if such a structure were ever to fail, the consequences would be unimaginable. This is where engineering reaches both its greatest achievement and greatest responsibility. On the northern side of the dam, another marvel exists, a giant shiplift. Massive vessels, weighing up to 3,000 tons, are lifted over 100 meters in minutes, as if gravity itself has become negotiable. The river doesn't just flow here, it rises. Then comes Lujiazui, Shanghai's financial heart. Lujiazui. Here, skyscrapers dominate the skyline, like symbols of economic power. And above them all stands one giant, the Shanghai Tower. Shanghai Tower. At over 630 meters tall, it is among the tallest buildings in the world. Its spiraling design is not just beautiful, it serves a purpose. The twist reduces wind pressure, improves structural stability, and increases energy efficiency. Inside are some of the fastest elevators on Earth. They move so fast that dozens of floors disappear in seconds. At the top, Shanghai stretches endlessly in every direction, a glowing ocean of steel and glass. But perhaps the most incredible thing about Lujiazui is not what it is now. It's what it used to be. Only a few decades ago, much of this area was industrial land. Today, it is one of the most important financial districts in the world. This is the speed of transformation in China. Not centuries, decades. Luxury in China also pushes engineering to extremes. Take the Intercontinental Shanghai Wonderland. Intercontinental Shanghai Wonderland. This is no ordinary hotel. It was built inside an abandoned quarry. Instead of rising upward, much of the structure descends below ground level. Several floors are underwater. Guests can sleep surrounded by glass walls, watching marine life drift silently outside their rooms. It feels surreal, like staying inside a futuristic underwater world. Construction took more than a decade and required over 40 patented technologies. Engineers described it as a battle against gravity itself. In China, even hospitality becomes an engineering masterpiece. Then there is transportation. And few projects demonstrate China's ambition better than the Shanghai maglev. Shanghai maglev. Unlike traditional trains, this system uses magnetic levitation. No wheels, no direct contact with tracks. The train floats several centimeters above the guideway using powerful magnetic fields. Friction disappears. The result? Speed that feels almost unreal. The Shanghai maglev reaches 431 kilometers per hour in commercial operation. But what matters most isn't just speed. It's what China learned. Engineers studied every detail of the technology: stability, efficiency, infrastructure precision. Then they improved it. China moved from operating 431 kilometers per hour systems to testing 620 kilometers per hour prototypes. Now researchers aim for 1,000 kilometers per hour. At that speed, rail begins to challenge aviation, and this is only the beginning. Future systems may travel through low-pressure tubes, drastically reducing air resistance. The goal is not simply faster transport. It is redefining distance itself. Because when travel time collapses,